aqueous to begin. In the end, you will find that one precipitates and one stays aqueous.
Now I can't find silver.
47.
47? Thank you. Oh, I was stupid. Nice. It's like that's so funny.
Do I change like the solid? It depends on the reactive. So you have to look at this.
For the what you're asking, are you asking for the one that becomes solid?
Yep, that's what the precipitate is. Yes. Yep.
They'll be mad at me.
Questions?
No.
Good. Get to work.
Okay.
Well, you got no paper out. You're not doing anything. I can tell that.
Listen.
I'm listening. Go ahead. What?
There's no scrap paper.
Go ahead.
I don't want to write in my notebook.
What? There's no scrap paper?
Oh, okay. Well, I didn't know that's where you put
When
it.
did we run out of scrap paper?
Okay.
I wish you would have told me that. Because I would have taken more out.
Thank you. Thanks.
You need a piece too?
No, I
Are
already
you
used my
sure?
notebook.
Oh my gosh, you used the notebook?
We hate using notebooks.
Oh, good news. Get more scrap paper too.
Oh, no.
But this is the last of a dying breed, just so you know.
Wait, Mr. Brand, can you come up with
AL.
Did I
And then nitrate. AG. It's AG1. AG.
Okay.
And this
I need help with writing.
What do you need?
And then so turn it to
Am I flipping them or am I just putting them the same way and then changing?
Well, here's the thing. If you put them the same way, that's no
You
reaction.
poison
So
yourself.
something has to change places with something. So what's going to change places with what? No, you got to take the metals from both of these and switch what they're with. Even if you just change the order, that's no reaction because you would have the same thing before. No, metals always go first.
So I would, when I put the
No, they need to change places with each other.
so it would be AL3 plus AgCl.
So I just
Well, remember to check charges when you do your compound, but yes, Al would be with the NO3, Ag would be with the Cl. Yes.
like so aluminum chloride. So you would just do like the AlCl.
Okay, what do you do?
So for both the aluminum chloride and the silver nitrate, that's just how
You
you
gotta
get.
put it with
Like you just write them like that.
silver
And then you're looking for how many grams of precipitate will be produced. He said it's a double replacement reaction, so we're just put the metals. So instead of AlCl, it's gonna be AgCl, and then AlNO3.
But you
And
need
then,
that also be silver nitrate.
You just have to figure out which one is gonna produce the precipitate. By looking at this one,
Mr. Brand.
Okay.
and so
Sorry.
which one's gonna be
Yes,
solid.
Olivia.
Yeah, it's okay.
Well, now you gotta tell me those are your reactions.
That's like,
Now you gotta tell me what you
but
create.
then also the first event is this
Okay.
infiltrate, so
I'm gonna wait.
Oh, yeah.
Ella, Aiden, and for the
N-O. Wait. N-O. Wait. Parentheses. N-O. 3.
All right, aluminum chloride. Give me the formula for aluminum chloride, Cynthia.
What?
Give me the formula for aluminum chloride. AlCl3. All right, and it is aqueous.
We can't see what you're writing.
Sorry. Okay. It is reacted with silver nitrate. Give me the formula for silver nitrate, Alexis.
Oh, AgNO.
And it is aqueous. Okay. Now, the question is, what do you produce? What do you create? Okay. Sorry, this pen is driving me nuts, ladies and gentlemen. I'm going to switch. So again, we had aluminum chloride. If you're not sure on how we got the AlCl3, aluminum is a +3, chlorine is a -1. That is why it's AlCl3. Plus silver nitrate. Silver is a +1. Nitrate is a -1. That is how we get that, ladies and gentlemen. Now, this is setting up to be what kind of a reaction? Double replacement. In my example to you earlier in the year, a double replacement reaction is like going on a double date. You have two couples going together on a double date. Things don't work out, things aren't working out, so they decide to switch the couples up. Now, when you do that, if you have a boy and a girl going out with a boy and a girl, you don't end up with two boys and two girls going out at the end. So the boy needs to change places with the boy in the other relationship. Well, the same is true here. This metal, aluminum, needs to change places with this metal, silver, and to create what they're with. Now, I don't care the order that you write them with on either side. These two things are on the reactant side before the arrow. Now you need to write the products by switching the silver and the aluminum, what they're with. When you do that, please make sure you recheck the charges of what they are going with, because you're not just going to write AgCl3 because there was a 3 here. You need to write a balanced compound for that. You need to write a balanced compound for aluminum with nitrate, ladies and gentlemen. So that is the first thing that you have to get done in this problem, is get a balanced chemical equation written. So, if aluminum and silver are going to change places, Lizette, what is one of the products that will be created if aluminum and silver change what they are with? So this aluminum and this silver need to switch places. What will be one of the products? What do you think? If this and this switch what they're with, what is the silver going to be with, Lizette? Cynthia, please put away your phone. Your phone that is on your lap, please put it away. Thank you. What? I'm sorry, I can't hear you.
It's gonna be with chlorine.
Okay, so what's the formula for silver with chlorine? What's the charge on silver? What's its charge based on the periodic table? Okay, silver is a +1. All right, what's the charge of chlorine?
1.
What kind of one, Lizette?
-1. So what would the formula look like when you put these together? Very good. AgCl. Okay. The other product that we would create would be aluminum with nitrate. Yes, Ava.
Does it matter which one you put first?
It does not matter the order, no.
Okay, thank you.
Okay. So, Ifra, what would we get when we put aluminum with nitrate? Just like this? Okay. Now, aluminum is a +3 charge. Nitrate is a -1 charge. So yes, AlNO3 in parentheses with a 3 after it. Okay? Now you need to go to your solubility chart, ladies and gentlemen. The one that is on this side here. And you need to look at the two products that are created, silver chloride and aluminum nitrate. One of them has to precipitate or there is no reaction. Which one precipitates, Austin? AgCl will precipitate. It will be a solid. Aluminum nitrate, nothing precipitates with nitrate, so it will stay aqueous, ladies and gentlemen. There we go. Questions? So now we have a balanced chemical equation written. Ladies and gentlemen, if you can't do this, you need to come and see me and get help. Why? Because if you can't do this, you cannot do the problems that we are about to do. Okay? You cannot. If you can't get this, you are in trouble. All right, so now, ladies and gentlemen, we are going to balance this. Al, Cl, Ag, and I'm going to keep NO3 together because it is together on both sides. All right. How many aluminum on the reactant side here, Olivia? Product side for aluminum? 1. How many chlorines on the reactant side here, Rocio? How many on the product side? And don't worry about this. We are going to take care of this. You have to write good compounds first. The compound says it's AgCl. The compound on the other side says it's AlCl3. You cannot change those. All right, how many silver over here on the reactant side, Farhan? Silver. 1. How many on the product side? Really? Really? Yeah. Are you just making up numbers as you go? How many on the product side? 1. And I said, really? And all you had to do is say yes. All right. Aiden, how many NO3 groups on the reactant side? Really? Good. How many on the product side? Really? Good. Okay, so now we need to balance this off. We need to balance 2 things. We need to balance chlorine. We need to balance nitrate. Which one do you want to do first, Yuritsi? Okay. Which side needs more chlorine? Left-hand side or right-hand side? Okay. So in front of the compound with chlorine over here, what number do you want me to put in front? Let's put a 3 in front. Okay. Now that does change the amount of chlorine to 3. What else did it change, though? To how many? Okay. Fine. We got 1 balance. If everything works out in the end, it should work out. All right, Leaf, now what do I do?
You put a 3 in front of the AgNO3 on the left side.
Put a 3 in front of the AgNO3. Now, the reason I do this under the arrow is so that I can keep track side to side, ladies and gentlemen. Side to side. When I put a number in here, I update everything that I changed. Now I put a number in here, I'm going to update everything. That's 3 Ags, 3 NOs. Everything is balanced now. Questions? Okay.
How is that 3 NOs?
There's 3 NO3 groups over here because it's in parentheses with the 3 around it. So that means there are 3 of these groups. So on the other side, there was 1 of the groups here, but putting a 3 in front now triples that. It goes to everything. Goes to everything. Okay, so here's what we're given, ladies and gentlemen. Whoa. All right, I am given 28.9 grams of aluminum chloride. I want to know how many grams of precipitate. So we do our simple, well, not our simple, but we do our 3 steps. First step, what is it? Okay, take what you're given, get it into moles. We don't have it in moles, we have it in grams. So 28.9 grams of AlCl3. We're going to get that into moles, ladies and gentlemen. Aluminum, 26.9798 on your periodic table. Chlorine, 3 times 35.45. So that's 106.35. That's 133.33, I believe.
Yep.
Over 1 mole. That will get us out of grams and into moles, ladies and gentlemen. That is step number 1. What is step number 2? Molar ratio. Always the moles of what we are in and the moles of what we are going to. We are going to silver chloride, so that goes on top. 3 moles of AgCl. On the bottom, 1 mole of AlCl3. I'll clean up this area over here. Give me just a second. Okay? So, taking what we've given, got it into moles. Use the molar ratio. What is the last step? Turn it into the unit you want. The unit that we want is what? Grams. But now, ladies and gentlemen, it is grams of aluminum or silver chloride, not grams of aluminum. So silver, 107.487, sorry. Chlorine, 35.45. So that, ladies and gentlemen, gives us 143.32. Grams of aluminum chloride cancel out. Moles of aluminum chloride cancel out. Moles of silver chloride cancel out. And we are left, ladies and gentlemen, with grams of silver chloride. Exactly what we were looking for. So we take our 28.9 times 3 times 143.32 divided by 133.33. Should be around 90 some. Maybe a little more. What do we get?
I got 93.3.
You got 93.3? Anybody else get that?
93.2.
Okay, I'm close enough. We'll go.
Yeah.
Grams of silver chloride. Questions? Aiden.
Where you bring the molar ratio?
The molar ratio comes from the coefficients that are up in front here. This 3 is where I get this 3 from. There is nothing in front of that. That means it's a 1. Okay? So this accounts for the fact that for every one of these, you are going to make 3 of these. And that is done right here in this step. Okay? This step can compare any 2 parts of this equation. Anything in here to anything else. Okay? That's why we do the balanced equation. It allows us to get that. Questions? Okay. Now, before I forget, Monday is your quiz. You know the problems that you were supposed to do yesterday in the lab? Those are the kind of questions that are going to be on your quiz on Monday.
Is it just gonna be molarity?
Just molarity.
Thank God.
Is this molarity that we just did?
This is not. Molarity was the moles and the liters of solution, those problems. So, yep. We're going to start out slow, get you a quiz that you should do well on, get that in the books, and then we'll get it worse as we go through this unit.
How many quizzes?
It's about 3 weeks, so probably 2 quizzes. Okay? Questions? All right. Yesterday,
He just whispered at us.
Yeah.
I tried to get your attention. Okay? No, it didn't. So, yesterday we did the video of how to go from use gas laws in these problems. Questions?
We were all laughing when we were watching the video. You were
Why do you
asking
keep
us
making
questions.
Yeah, you were like, any
Well, here's your
questions?
chance. Go ahead.
No, we just thought it was funny because you weren't here to answer, and you were like, any
I understand that, but again, if the videos are made for if you're absent.
Did you
So-
post that in Classroom?
What?
The video?
Yeah, it's in Google Classroom. So again, don't think that if you're watching the videos at night at home because you missed class that day and I ask questions and I'm going to answer them when you go, yeah, I don't know how you got that. Okay? Just so you understand. I'm not the Kool-Aid man. Okay? Nope. You guys have no idea what I mean by that, but that's okay.
Yes, we do. I know who the Kool-Aid is.
You guys know who the Kool-Aid man is?
Oh, yeah.
Awesome.
But the real question is he the Kool-Aid or is he the jug?
The jug.
The whole guy is the Kool-Aid man.
No, but like, because there's a commercial where he's no Kool-Aid, just jug.
What?
He's just like the cup.
Yeah.
What?
Like the container.
Yeah, and the
What
Kool-Aid
kind of
thing-
idiot thing is that? Okay. Packet. Get to this problem. Number 9 in your packet, ladies and gentlemen.
What unit is this?
This is the first worksheet. This is number 9.
Are all of these problems in this first week's worksheet the ones we just did?
Are the ones we just did.
Like the one we just did together in class? The one you were
No.
going over?
No, the one that I'm about to go over with you is different. That's what I'm getting at. All right.
It's Friday.
All right. If 7,515 liters of sulfur trioxide gas reacts with water in a synthesis reaction at 18 degrees Celsius and 0.828 atmospheres, what mass of acid rain, sulfuric acid, is produced? Okay. First thing you've got to do is write a balanced chemical equation, ladies and gentlemen. So let's start with that. Let's begin with sulfur trioxide. Somebody, please. SO3. Please remember, these formulas that have the prefixes in them, tri, di, tetra, you do not need to balance off charges. These are covalent compounds. So we write what is there based on the prefixes. Since there's no prefix at the beginning, that means there is one sulfur. The tri means 3, oxide means oxygen. So SO3, and it is a gas. It reacts with water. Someone, formula for water. Good. State of matter. Liquid. Water cannot be aqueous. Water causes other things to be aqueous. Aqueous means dissolved in water. That is what aqueous means. Synthesis reaction. What does that mean, ladies and gentlemen?
They combine.
Only one product. They combine into one product. Good. Sulfuric acid formula. No.
H2SO4.
Very good. Sulfuric acid comes from sulfate. Sulfate is SO4. Sulfate has a -2 charge, so we have to put 2 hydrogens with it to balance it off. What state of matter is an acid? Always aqueous. Okay? Now, hydrogen, sulfur, oxygen. 2 hydrogens over here, 2 hydrogens over here. 1 sulfur over here, 1 sulfur over here. 4 oxygens over here, 4 oxygens over here. Everything is balanced. Questions?
And you said for these ones we don't have to balance it out?
Yes, you do. That's what I just did. I was just balancing it.
Oh.
Okay? You always have to balance your chemical equation. Otherwise, you will not get the correct ratios. Okay? Now, for this one, ladies and gentlemen, what we are given 7,515 liters of gas under the following conditions: 18.0 degrees Celsius, 0.828 ATM. We are asked to find what mass of sulfuric acid you would create. Mass is in grams. Okay? Now, what information are you given about the gas?
How much they're doing?
Specifically, what unit? Volume. Liters describing volume. What is 18.0 degrees Celsius? And what is 0.828 atmospheres? Why are they giving you all that?
Herbert formula.
For PV equals nRT. So what do we always do? What is our first step? No.
Calvin.
Take what you're given, get it into moles. So we are given a pressure, a volume, and a temperature.
So
We have to use PV equals nRT to get it into moles. Okay? Now, what R value are we going to use for ATM?
0.082.
So I've got everything I need here. 7,550. Oops, sorry. I'll start with the right unit first. Pressure, 0.828 atmospheres. Volume, 7,515 liters. Number of moles, what we are solving for. R value, 0.0821 ATM times liters over mole times Kelvin. Temperature, what is it? 291 Kelvin. Please remember, ladies and gentlemen, it is of the utmost importance. This has to be in liters. This has to be in Kelvin. There is no other units you can use there. That's what they have to be in. Now, Cynthia, you will love this problem. Why? Because unlike the other ones where we just string them all together, you can't do that here. You have to first find the number of moles. Okay? So it doesn't work out that it easily goes into the problem the way the last one did. So we're going to first find the number of moles. So when we do the math here and we solve for N, now remember, we're going to isolate N by dividing this side by 0.0821 ATM times liters over mole times K and 291 Kelvin. What we do to one side, we are going to do to the other. So now, N, what do we get?
I don't trust my math. I got 260.4.
Moles of what?
Sulfur trioxide.
Good. Questions? Now, good and bad about this problem. The good is Cynthia hates those problems where I put them all as one big long problem. She doesn't like that. She wants to solve each one individually. Fine. This one, you do that. The bad, people forget the second step of the problem. What's the second step of the problem? See, you forgot it already. The molar ratio step. You still have to do the second step. You still have to do the ratio. Okay? Now, the ratio, ladies and gentlemen, is 1 mole H2SO4 over 1 mole of SO3. And now Cynthia's going, well, Mr. Brand, that's just by 1. Why do I need to do it? Because you still get a point for it when you calculate your answer. And if you don't do it, I'm going to mark it wrong. You need to show me a ratio step. Yes, it is 1 to 1. I don't care. You need to show it to me. Questions?
So you mean we have to show it, but we don't have to do it because the answer.
Well, you never have to do any math where you're multiplying or dividing by 1. But you do need to show me that you took this times the ratio step, because it's the only way to get from SO3 into H2SO4. We still need to switch what we are in. Uh-oh. Mr. Brand. Yes. Excellent. Thank you very much. Bye.
I have a surgery consult.
You're out of here. Go away.
Thank goodness.
Go away. Goodbye. Goodbye. Be ready for your quiz on Monday. Okay. So, taking what we've given, gotten it into moles. Use the molar ratio step. What is the third and final step?
Convert to units.
What units? Grams. How do we get to grams?
Formula mass.
Formula mass. I'm glad you haven't left yet, KP. Formula mass of what?
The
H2SO4.
H2SO4.
So, 2.02, 32.06, and 64.0. That is 08. That is 98.08. By the way, ladies and gentlemen, these problems become a lot easier when you don't have to pull out a calculator for every math that you ever want to do.
Well, some of us aren't smart.
Oh, I'm sure you are smarter than me in a lot of ways.
I know I am.
I know you guys are too, but I'm not afraid to do math. So, final answer, 260.4 times 98.08, probably about 2,600?
5540. 25,540.
Why do you try doing your head when you could just?
25,000.
Yeah, I'll buy that because you're taking it times almost 100. So, and that is grams. So 25,500 grams of H2SO4. What? Taking 260.4 times 98.08. That's what we get. Then I rounded it into 3 sig figs, so I dropped the 4, made it a 0, so it wasn't significant. Left the 5 where it was. Questions? What's the matter?
pooped out.
Why?
Because
You haven't even used your brain yet today.
yes, I have.
Farhan, where did I get 260? You see this calculation up here? When I solve for n, that's what I got. Did you try to do that on your calculator? What bottom one? So you're telling me 0.828 times 7,515 divided by the quantity 0.0821 times 291 in parentheses, and closing the parentheses, gave you 260.4. So you did get 260.4? Bring me your calculator. Don't do anything. Okay, dude. Don't put both of these in separate parentheses. Put them in one set of parentheses. Yes, together. Now watch what a difference this makes. Again, this is why, ladies and gentlemen, please listen. If you're sitting there and you never do a calculation in class, when you do have to do a calculation, you end up with the wrong number and you don't know why. Instead of being able to say, Mr. Brand, I'm getting a number that's much larger than this, and I can come over and I can check it and say, don't do this. But again, it's terrible when you find out on your test that you don't know how to put numbers into your calculator to get the answer you want. There are different ways of doing this though too. Okay, you could do this number times this one divided by this one divided by that one and not put any parentheses in. You'll get the 260.4. You got to figure out how you're going to do your calculation so that you get the right answer. Okay? But again, if you won't practice them in class, it's just like anything else. Okay? You don't practice it, you're not going to get better at it. Questions? Okay, go to work on your worksheets, ladies and gentlemen. If you have questions, I will be more than happy to answer them for you. What? Go ahead.
Oh, yeah. Yeah, 110.
110?
It's like 30 minutes to get there, and then.
It is not 30 minutes to get to see home.
Well, the first event starts at 3.
Yeah, because
Yes! Go for it.
I see it. So 1:30?
120 or 110. Oh, you leave
The
class.
bus leaves at 1:25.
And then the 110. So during city hall.
Well, first of all, it depends. You may have to use a polyatomic, which is on the back here.
2 stories.
No, it doesn't create a metal. It's just that is what the metal is with. So these polyatomics are in a lot of compounds. So sodium carbonate is sodium Na,
I'm taking that.
number 11, and carbonate, CO3, bottom of that far white sheet up there. That's on the back of your periodic table. Now you've got to write a compound for them with that sodium plus 1 and that carbonate NO3, CO3 minus 2. To write a compound for them. That's what we did before. No, I said Na and CO3. Sodium carbonate. No, because you didn't put the CO3, you didn't put the 2 by the Na, did you?
I think I remember what you
No, dude.
She doesn't have
What's the charge of Na?
Yeah, I know.
Positive 1, right? What's the charge of carbonate? Now you got to make a compound so that they have no charge.
I'm taking it next time.
That's the part you're forgetting. Okay, now find it on here. CO3. Will it be aqueous or will it be a precipitate?
with Na.
Can I go to the bathroom?
No! Na is a cation of column 1. Column 1, the first group, column 1. Lithium, sodium, potassium, rubidium, cesium, and francium. You know what's killing you? Your vocabulary.
I like tokens.
Okay,
Wait, who?
okay, good, good, good. Now try to write a formula for one of the ones on there, yeah.
I don't like that. Woman's nicer with it.
Well, the quiz on Monday was the problems I gave you yesterday.
Yeah, she helped me.
So, these are beyond that. So like the problems that I gave you yesterday, those are the ones that are on the quiz. Okay, the ones that are in the first stages of the notes. Molarity, those are the ones on the quiz. Just the ones that I gave you yesterday.
Yeah, she's
Right?
girl. You guys still have to have your drinks.
For what?
Oh, it's
Oh, nobody does that.
For what?
What?
So you're asking me to use your phone in the quiz? Or?
No, none of this.
I don't even know. I'm not doing it right now.
What if I wrote a bubble?
I'm doing the molarity process like these pieces.
I didn't drink it.
Yes, Olivia. Yep. Well, remember, the 2, that Roman numeral 2 is telling you that lead is a plus 2 charge. That's what it means. By the way, if you see a problem that says calculate the percent yield, I haven't shown you how to do that yet, but you can do all the rest of the problem except for that. There you go. Good. You bet.
Which one of the molarities? Which ones are the molarities? Just go to it. It says molarity. Just look here.
What did the Toll Brothers do?
One was a butcher, one was a cobbler, one was a candlestick maker.
Okay, but what does that have?
One huffed, one puffed, one blew the house down.
Toll Brothers, I don't know this.
Can I ask a question? You go to your language arts teacher, go, how do you figure out molarity?
Yeah, I do actually.
Really? What do they say?
Well, I'm not taking LS. But I will. Wait.
So you realize there's a part on there about, doing what you're supposed to and being on task and things like that on that survey that you just asked me to fill out.
Okay, you can give it back.
Here you go. Okay, you can find somebody else, that's fine. Those questions?
Are you talking about it was open.
There were problems on the back of the tables yesterday.
How was Qdoba? Oh, it was so yummy. Yeah, I have like
Yeah,
new,
this is
like,
separated. Okay, yeah.
they don't have new corn, but they're like squirrels.
Yeah, yeah.
I have one
I don't know.
Take those things before you go.
Yes. I actually love that.
Here you go.
one.
Jennifer,
It's
it's
right
okay.
on my mind. Really? It's literally next to it. That's so funny.
Oh, yeah.
Yeah, I like to have a bit of the milk bay sometimes when I want to eat.
I like
Because
Time management, oh, I get to fill this out.
I thought you said you didn't want to.
No, I asked you if you wanted me to,
I told you, I gave it to you, then you were like, you want it back?
Oh,
and you said yes.
So really, you don't want it because you're asking for it back.
yeah. Yeah, they don't also do.
Please describe this person in
If you don't
20
get like a
words
special
or
feeder and have
less.
little bay, it's not that
Or 39.
Or 39.
Oh, no, I thought you said.
You had bad timing with your comments. Bad time, bad time. There's no such thing as bad timing until then.
Oh. Oh.
I know how to start it.
Are we talking about chemistry?
Yes.
Okay, so what's your question? No, be honest, what's your
The
question?
molarity was used.
Like I know how to
Stoichiometry.
Well, the first thing we have to do is start with the chemical reaction. Balance equation.
Oh.
So magnesium is metal. Write down magnesium metal.
I really want to, because I mean,
Put in that by it.
our quiz is on molarity, I don't have to know it.
Why? Because any metal that's alone like that, we'll just put in it by them, okay? Plus, hydrochloric acid. Now, be honest, you know how to do hydrochloric acid. Okay, hydro means your acid is binding. That means there's only two elements in it. One element in every acid is what? Hydrogen. It's gonna start out with H. Now, where do you think the chlorine comes from? What element makes it chloric acid?
Chlorine.
Chlorine. So put it with chlorine. Now, what's the charge of chlorine?
So just write what you got.
1
Plus 1. Or minus 1.
minus 1. What's the charge of hydrogen?
Plus 1.
So what do you need to do to them? Anything? Nothing. They balance out. What do you put by HCl?
2.0 moles.
Because it's an acid.
Oh,
What do you
aqueous.
aqueous? AQ. Okay. Produces an arrow. Okay. Magnesium chloride. So what would magnesium chloride look like?
Big M equals moles over V. So
Good. By the way, any compound in a single replacement reaction like this is going to be aqueous. And now write hydrogen gas. That's the other problem. What's that?
Oh.
have to multiply by L.
Gas.
And divide by 1.2.
Which is the mole.
Now, balance it up. One magnesium, one magnesium. One hydrogen, two hydrogens. One chlorine, two chlorines. So what do we need to do to
Just
balance?
multiply by L. Right, so put L.
Which side needs more?
To cancel out the L and put it over here. And you have to divide by 1.2.
Okay, so put a two there.
I don't have L.
Now, if you can do that without setting up the scoreboard and
We
things,
multiply by L.
not a problem, I don't care.
Just multiply.
You just gotta get it right. You're good. Okay, so now what do you get?
Multiply L.
20 grams of magnesium.
Yeah.
Okay, so underneath magnesium, I put
Okay, because technically if you
20.0.
multiply
Just
this
to
by
remind
L,
me,
it's gonna
this
be
is
on
what
the
I got.
top, and then they cancel out.
What are you looking for?
And then L comes over here, and then you have to divide by this.
Okay, so under that I'll put
And then divide by this.
question mark grams, just so I know. Now, do the problem like you said you know what to do, right?
Uh-huh. So 20.
So multiply both sides.
Take what you're given, get it into molar ratio, convert out into your final unit.
Okay, so Brand.
Okay.
Now what? That's it?
Now what? I have no more questions.
24.31 grams is the formula mass of magnesium. And 1 mole.
That's it. That's it.
So, is it right?
It looks like it, yes.
1 mole, that's unnecessary. Okay.
No, well, here's the only thing to do. This is just moles. It belongs over here.
Wait, no, because you're.
This belongs up here as 1.20 moles of NaCl over liter, because that's what molar is.
I'm not sure.
Oh.
So those should be switched. Now, it doesn't affect you mathematically, but they need to be switched, because this is only moles, and this molarity is moles per liter. Okay? So- By the way, I guess there are some molarity problems in your packet, ladies and gentlemen, if you want to do so.
You're a liar.
Well, where-
They're the packet.
And
That's a
then
1.67. You said it was right.
MgCl.
Why'd you multiply?
See, I did it right.
Oh, hang on. Flip this. Flip this.
It's like,
Wait,
can you
it's
flip
multiplied.
it?
I mean,
Wait, you know.
Yeah.
Okay, never mind.
I thought I should have molarity.
It's
No, I
like
wrote it.
two.
I don't get that.
No, because To get
Oh.
moles by itself.
You'll know what's in between this and there,
Divided by this,
equals.
So it's not divided by that.
So this equals this. Hang on.
Can we have
Yes, that.
Why did I get the answer this? Why did I get
Here you go.
Oh, okay. Why did I get to before this?
Because here's the thing. Here's what you're missing. Give me your pencil.
So you already know the
Oh.
First of all, let's fix this. Where's your eraser?
I think that's.
Well, you know, so
You can flip on snappers.
my bad.
Yeah,
So here's the thing, okay? How many liters of this solution would contain 2 moles of this? So if I'm gonna put 2.0 moles of this
Okay.
and take it times the molarity, okay? 1.20 molarity is 1.20 moles of NaCl per 1 liter. If I put this way, moles don't cancel. So I have to put 1 liter or 1.20 moles so that the moles will cancel. And what happened was by swapping those, it would have been fine doing it the way we were doing it, but we were looking for something else.
So that's what my answer to
You multiplied it instead of dividing it. 1.20. There you go. So this is how you have to think of this. Because then I could put it moles on top, liters on the bottom if I'm in liters. Or I could put moles on the bottom, liters on top if I'm in liters. Does that make more sense? Shoot.
What do I divide this by when I'm doing it backwards? Like when I have the molarity?
Okay, here's what I would do. And this is what I was just explaining to Cynthia.
Oh, I'm sorry.
No, that's fine. You're gonna start out with this 2.0 moles
Yes.
of NaCl. This is equal to 1.20 moles NaCl over 1 liter, okay? If I'm gonna use this as a conversion factor to get from moles to liters, what has to go where in here?
Just in there? Not like
Not the mole, look at this.
Oh, yeah.
Which part goes on the bottom? Okay, put it, I thought I heard you say something different of what goes on the top. So let me see what you would put on the top.
So I don't put the mass on the top,
Well, that's not mass.
so I put 1 liter on top. Is it always 1 liter?
Well, in molarity, yes.
Okay.
This molarity means this.
And then I
Now.
convert the moles to. I convert the moles to.
No, because it doesn't ask you to.
Oh, it's just.
It wants how many liters. Well, look, moles and moles
Oh,
cancel.
so I already have the moles, so I just need the liters, right? Okay.
So this conversion will let you go from moles to liters or from liters to moles.
Okay.
That's what molarity does. Yes, sir.
Your things are ugly, be honest. No, they're so pretty. Really? Yeah. If I wore them.
Well, again, the reason it's confusing you
It would be weird.
is because you're writing this way. This, I would write this way.
They're literally so cute. That's what I was saying too, so.
Now, I can leave that this way or I can flip it over. Okay? So, what are you beginning with? How much? So put 2.00 moles.
They're my favorite flowers, right? I was like, oh my god, they're so pretty. And I showed Josie and she was like,
No, moles. Write out moles. Don't write out M. M is different. Okay? So now, use this to get it out of moles and into liters.
Both sides. Back out and divide that by 1.
No, that ain't gonna work.
And
That isn't gonna allow you to cancel moles. The only way you can cancel moles is if moles is where. So you need to put moles on the bottom. You need to do what to this?
What?
yeah.
So you cancel out later, so.
Like, I was telling Alexis this morning. But like,
We need to flip it over so that the moles will cancel and you're now left with liters when you're done with this problem. Okay?
Because I'm so used to it,
Yes.
because I'm all the time. And then like later I'll be like, wait, that was like a fucked up.
Divide.
Like, and it's horrible. But
Again,
because
here's the thing that you guys are killing yourself.
She does this all the
And
time.
you're using my charger to charge your phone, go ahead.
And then like later on I'll be like, wait.
This
I'll be like, wait.
is 5.90 moles.
No, literally I told her.
18.03
No, I told Lucy
per
about
1
yes,
liter.
and she knows me. And I was like,
I could also write this 1 liter over 5.90 moles of AgNO3. I can write it either way,
and it's
Either
so
one of
insane.
okay?
Like I
Get rid of this.
the feeling this way since
You're starting out with 3.3 moles.
I was like, what
If you want to get humility,
actually, yeah. And then
That's
so
right.
which one of these are you going to
it's
use
what I did more.
to get rid of the moles here?
So yeah. Okay, so then,
This one or that
you
one?
guys get.
Oh wow, foundation.
Like,
So I'm not like, I don't know if it was yesterday actually.
You can cancel it,
That I saw her wearing
and then look at what you end up with.
Hooray. Yes.
Why do you
Girl,
start?
she smacked that shit
Because
out.
that's what you were given. How much of this would contain this many moles of silver nitrate?
Like I
So
get the vision.
that's how many moles I'm given. We're gonna use the molarity
I
and
work
we're
that out
gonna find the
personally.
volume. Molarity is a way of going from a unit of moles to a unit of liters. Okay? So you're looking for milliliters and you're given moles. So you're gonna use molarity to get from moles into liters.
But then she didn't get out of it. Just a little bit. Like I was trying to get out
That's
a
what
little bit.
molarity does.
I saw her in the clothing.
You have a question?
Yeah. So like, what I do that, where do I put the, because I have the liter.
Well, again, start with the liters first.
So I start
Correct.
times 1 liter on the bottom,
Made me
and
so
then this on the top, but it's moles.
Yep.
Okay.
Yep. And then your
And you're
liters will
wearing
cancel
like-
out and you will be left with
Get out.
moles in the end.
Thank you.
That's what molarity does. It allows you to get from volume to moles or moles to volume. Yes, sir. Nope, you got it wrong again, dude.
Yeah.
This is not just moles. Molarity means moles over 1 liter. That means this number of moles over 1 liter. You just wrote it as moles again. You got to do it as moles per liter. You can't change what molarity is. Molarity is moles over liters, always. No! Over 1 liter.
Oh no, I'm very social.
Molarity is moles over 1 liter. Now, you have 4.45 liters. Start with that.
Hello.
It's just.
Because she got that liquid confidence.
And what will you do when you're done? There you go. There you go. Moles cancel that out. There you go. Yes, Sophia.
For this one, you get like this, just like the last part, and then sort it into later.
All you have to do is you have to find either the moles or the liters, and then you take
So,
moles.
you're going to start with that, right?
Oh yeah, so this one, when I get 8,
Yeah,
Yeah, but that's what I'm trying to take what you said in part.
and then I have
Start with that.
4, 5
Okay.
liters, so I
You're
take
going to get it into,
the liters first,
then
and
use the
then
ratio.
divide it by liters.
Now, when you come out, it wants liters of
And then
gas
on
at
the top, I
STP.
would
So
do
what do
the
we use to
number
get
of
from
molarity,
moles
but
to
as
liters
the-
at STP?
And then, so that's gonna give me.
That'll be probably the last time I ever give you one like that.
I mean, you can, but if you
Yes.
get the molarity, try to put it. Instead.
Yeah.
What?
Okay.
Divide, what?
35 liters.
It felt
Here's
small.
what-
Maybe I should
Yeah,
get
for
five.
number 2,
It was just a
35.8.
The main thing is
Divided
this
by
is
So like
moles.
you're being
and this
lost.
seems
Yeah.
to look okay. Okay, can I show you a different way? And if you like it, great, and if not, there's nothing wrong with what you're doing.
I wasn't really paying attention
So here's what I'm telling. This
How'd you get?
Yeah.
is
If your friends are really fun, then
0.90
you're gonna have a good time.
moles of silver nitrate.
Josie left, or not Josie, Allie left, and then I was just stuck with Josie.
But I could also write this one
Around
here
like fuck.
for 5.90 moles of silver nitrate. I could do it either way, right? Well, I want to know how many milliliters I've got liters. So I'm going to do this.
Girl, I'm literally.
Now, which of these do I use? So I'm gonna just turn over that
Please never
molar,
talk to me again, actually.
get rid of moles,
Literally, I never wanted to.
and I will be left with liters.
I thought you didn't like me.
Either way,
Really?
Because I tried talking.
either way. I
Really?
can't say it's always going to be the bigger one
How
on
do
the
you
bottom.
become friends?
I don't know
Bro,
what your numbers are.
Oh, yeah.
Well, we're like less.
We went through that. It's so funny. Like, we bonded over. I think we, like, became friends, like,
Well, what I'm saying is,
our first, like, the first real conversation we ever had.
I'm gonna take this side
It
and
was
this
like
leader
going to sophomore year. Like,
to get rid of.
we're like, oh, we have green.
And what I do,
We're
oh,
like, why are people on this?
that has to be an equal.
Yeah, that's actually true.
And what I do to one
And now we're
side,
like
I'm going
this.
to do to the other.
That's so funny.
Okay?
But yeah, I tried talking.
Now I'm gonna divide this side
the
by
first time we were there at a
5.90
rehearsal.
moles.
I was like, hey, because we were both in the back. And
Why?
you just
Because
didn't
I want to get
Oh,
the
really?
liters
I
down.
was like,
I'm
okay.
gonna do the one side, I'm gonna do the other.
Okay, to be honest, people say that to me all the time, that like
So
I
you end
ignore
up
them,
doing exactly
and I'm just
what
like,
I kind of did.
I didn't, like,
3.3.
I'm just
No,
dumb.
like,
I'm
it's
literally
fine.
just dumb and slow. Like, I can't help it. I just people come up to me all the time and be like, Alexis, why did you ignore me in the hallway? And I'll be like, I didn't, like, what?
That's what was funny.
So if you're solving for that one on the bottom, you gotta get it up on the top on the other side, and the one on the other side, you gotta get that down on the bottom. Okay? Does that make sense?
That's actually hilarious.
I don't think my way is
Okay.
but like.
So mathematically,
Let's go ahead here. No, I'm just slow and dumb.
No, I just need to hear it.
Maybe.
we need to get X.
Yeah, probably. I only talk to
do
like
that,
Eric and
I don't
Janine
want it on the
and
bottom.
like Isabel a little bit.
So I'm gonna multiply this side by
I
X.
remember that.
So I do it one
Me
side,
and Janine were like
do it the
this.
other.
Now we're like
So now I got
this question
72.6
mark.
times X.
We're like
equals
this.
14.3. Well, now, I still want to get X alone, so we divide this side by 72.6. And what I do to one side, and do to the other. So now I have X equals 14.3 over 72.6. So that's kind of what you were doing. Okay? So again, it's the math and how you want to do the math. There are different ways of doing the problem. Instead, I'm gonna start with this, and I'm gonna use this as a conversion factor. I just flipped it over so that the moles and moles cancel. And you'd be left with these.
So you have to find a moles, right?
So it's giving you moles and asking you for liters. It's giving you
But that
grams
would be
and asking
weird
you for
if
liters. Molarity can be the conversion factor between the two. Okay? If it's asking you to find the molarity, then you just flip the moles over the liters.
Yeah.
Okay?
Yeah, probably.
So it depends. Are you using it as a
Maybe she's
conversion
not
factor to
crazy.
get from liters to moles? Mole
Oh, I gotta
liters,
say-
or are you using it to find the molarity, in which
Yeah.
case there's only one
Like,
way to
is it
set
like
up
a-
next moles over liters.
Okay.
Okay?
She's crazy. And I can't take anything
Yes.
she says as like
That's why I don't like
really
this
what
one.
happened. You know what I
You
mean?
don't see what it's actually made up of. This shows
She
you
can,
what
like,
it's
give me a
made up
real
of,
reason
and allows you then
As to
to
why it was
use it.
happening. So that's the reason why.
So when you see molarity, if you think of it as moles over 1 liter,
Maybe.
now it can be used as a conversion.
Maybe she was on the truth
Okay?
for the first time in her life.
This is
Yeah.
right. You never
Do you
know.
have it? Like,
Well, you gotta do sig figs though. Don't forget about the sig figs, brother.
You can compare any two things in a reaction. Now, it's unusual to do that,
Yeah,
but
molarity is-
normally you're comparing a reactant product.
It's funny.
Yeah. You compare any two parts of the reaction. If you have so much of this, and you wanna know how much of something reacts with it, you can do that. You can do that. If you know you don't wanna make more than this amount of product, you could figure it backward and say, okay, don't start with any more than this reactant, otherwise you're gonna make too much. Okay?
it's unusual to have a product to predict the reactants, but it's not impossible. Okay? It's not impossible. Again, ladies and gentlemen, practice, practice, practice. It's the only way you get better at